Hi, it's Mr. Srikantapalan again, and I'm going to talk you through how to factorise expressions. I'm going to talk you through the various examples on the worksheet, going from example 1 through to example 5. But first, let's have a look at the key points. So, first of all, and this is very important, factorising an expression is the opposite of expanding brackets. You see factorising before you meet algebra when you factorise numbers, composite numbers. For example, when you factorise something like 100 using prime factor decomposition into something like this, and you state that 100 is 2 squared multiplied by 5 squared. So that's prime factor decomposition, or prime factorising a composite number. And when you're factorising an expression, you're finding factor pairs of algebraic expressions that multiply to give the expanded form. Okay, the second key point, a quadratic expression is in the form ax squared add bx add c, where a is not 0, so this is not 0. It's important to realise that b could be 0 and c could be 0. And that here you've got x to the power of 1, obviously you don't need to write that, and here you've got x to the power of 0, x to the power of 0 is 1. So you've got reducing powers of x, starting with 2, and where each power of x is a non-negative integer. Okay, to factorise a quadratic equation, you find two numbers whose sum is b and whose product is ac. That's a common strategy, and we'll see that in some of the examples. Here, they don't really mean a quadratic equation, they mean a quadratic expression. The title of the worksheet is Expressions. You will factorise in equations sometimes in order to solve them, but factorising doesn't only have to be done with equations. You factorise an expression to help you solve an equation. And they are asking you to notice a particular type of expression here, where you have the difference of two squares, and you'll have talked about this in GCSE, and it's commonly factorised into x subtract y, x add y, and if you expand these brackets out using the grid method, I'm sure you would get this. Okay, so we're going to have a look at example 1. Now, as you know, we use the grid method for expanding. Now, because we're factorising, we're still going to use the grid method, but this time, because we're factorising, it means that we already had 15 x squared y cubed add 9 x to the power 4 y in our grid. And this particular type of factorising in example 1, hopefully you can see there are some common factors between the two terms. And if there are common factors in every term, then that means we want all of the terms listed in one row so that we can write on this side over here the common factors, and we're looking for the highest common factor. So first of all, I'm going to look at the 15 and the 9. So we've got 15, we've got 9. Highest common factor there would be 3. So I'm going to put a 3 there. Now I'm going to look at the x terms. So I've got x squared, and I've got x to the power of 4. And I'm wondering what the highest amount of x's is that goes into both of those terms, and that would be x squared. Because x squared can be multiplied by 1 to get x squared, and it can be multiplied by x squared to get x to the power of 4. And then finally, I'm looking at y cubed. And y. Don't forget that this is really y to the power of 1. And in this case, y is the highest common factor of those two. And so here we've got 5 multiplied by 3 to get 15. We've got 1 multiplied by x squared, we don't need to write that in, and we multiply y by y squared to get y cubed. Okay, and then for the second part, I multiply 3 by positive 3 to obtain 9, I multiply x squared by x squared to get x to the power of 4, and I multiply y by 1 to get y to the power of 1. Don't need to write that 1 in. So 5y squared add 3x squared. And so, as you know from expanding brackets, the outline of this grid method would be referring to an expansion that looks like this. And because expanding is the opposite of factorising, this must be my answer to the question, factorise that expression. Now, it's important here, actually the question is worded badly, it's important here to realise that certainly at A-level they would expect you to automatically factorise completely. And so you'll see that in the worksheet they've achieved the same answer as I have, but it's possible, if you're not paying attention, to obtain a slightly different answer that wouldn't be wrong but wouldn't be complete. So I'm just going to do that here and show you how you can avoid this situation. So you may notice that 3 is a common factor of 15 and 9, and you may ignore the x squareds and the y cubed, etc. And so you might factorise this as 5x squared y cubed add 3x squared, x to the power of 4 y, which would get you an answer of 3 brackets 5x squared y cubed add 3x to the power of 4 y. And if you were to expand this, if you were to expand what I've just written here, you would get this answer. So you have factorised it, but you haven't factorised it completely. And the way you can identify that is because you can look at the bracket and notice that inside the bracket, your terms have common factors. And if that happens, you haven't factorised completely. And so then you would have to keep on going and say, well, x squared is a factor of both of those terms, so I can also take an x squared outside the bracket, and y is a factor of those two terms, so I can take a y outside the bracket. And you could carry on doing that in the grid, okay? But the quickest way is to see if you can spot the highest common factor of all your terms and put that here, and then you should only need to use the grid method once to factorise. Okay, on to example 2. This one is a difference of 2 squares. So you can see that you've got square numbers as coefficients, so 4 and 25. That's not particularly important. The more important part is that you've got x squared and y squared, and they're being subtracted. So this makes it a difference, and we're squaring the algebraic terms there. So this time, you would need to realise that this is a quadratic, a more normal quadratic, where it's similar to when you have 3 terms, and you would need a grid that looks something like this. And the key thing here, if you think back to expanding and the peanut, is that our peanut is going to give us 0. And the reason we know that is because in this expression, we don't have anything which has an xy term in it. So there are no terms that have xy, which means the coefficient of xy is 0. Okay, so what we do have is a negative 25y squared and a positive 4x squared. And we need to use the same terms. When it's a difference of 2 squares, we need to use the same terms here and here, and here and here, give or take a positive or negative sign in front of them. So I'm looking for something which you can multiply by itself to get 4x squared. Again, I'm going to focus on the numbers to start with. To get 4, I would multiply 2 by itself. And to get x squared, I would multiply x by itself. And then for the last term, I would multiply 5 by itself to get 25. And y by itself to get y squared. But here you can see that we need a negative when we multiply them together, which means one of them must be positive and one of them must be negative. And so we end up with, in these extra parts, the peanut, we end up with negative 10xy and positive 10xy. And you can see that when you collect the like terms inside the peanut, you'd end up with 0, which means that we would end up with 2x add 5y into 2x subtract 5y, and we factorised it. Okay. Normally I would come to an example like that after doing a more normal quadratic where there would be 3 terms, but they've put this down as example 2, so I'm doing it as example 2. None of this should be new to you, don't forget you've covered all of this at GCSE, so it should just be a recap. Okay, on to example 3. Now in example 3 we've got a quadratic where the coefficient of x squared is 1. You can pretend there's a 1 there. So we've got x squared, we've got subtract 10 in our grid, and we can see that the peanut this time needs to simplify to positive 3x. That's this term here. So to get x squared, I'm going to multiply x by itself. Now for the other part, I'm looking for a pair of numbers which multiply to give negative 10. So that could be positive 1 and negative 10. Or it could be positive 2 and negative 5. Or it could be positive 5 and negative 2. Or it could be positive 10 and negative 1. And so all of those pairs would multiply to give negative 10. However, I'm looking for the specific pair, which when I use it by multiplying by x, my peanut term will get me positive 3x. Hopefully you can see that the only pair that will get me that is this pair here, positive 5 and negative 2. So I need that as one of my terms out here, and negative 2 is the other. And then if I complete the grid, so positive 5 times x is positive 5x, negative 2 times x is negative 2x. Does the peanut simplify to give positive 3x? Yes, it does. So I would get x subtract 2 and x add 5, and I'm finished. Okay, on to example 4. Example 4 is more complicated because there is a coefficient of x squared greater than 1, and there's no common factors between the 3 terms. So this time we have a similar thing. We've got 6x squared and negative 10 in our grid. But this time, when we're looking for the numbers that go on the outside, we have to be more careful because we need to find a pair of numbers that multiply to give negative 60. Where's that negative 60 come from? It's come from 6 multiplied by negative 10. So if I multiply 6 by negative 10, I get negative 60. And so I need a pair of numbers which will multiply to give negative 60. So that could be positive 1 times negative 60, positive 2 times negative 30, positive 3 times negative 10, positive 4 times negative 15, positive 5 times negative 12, positive 6 times negative 10, positive 10 times negative 6, positive 12 times negative 5, positive 15 times negative 4, positive 10 times negative 3, positive 30 times negative 2, or positive 60 times negative 1. And we want the particular pair, which this time in our peanut is going to give us negative 11x. And so I look through my list of pairs and I'm looking for one that's going to give me negative 11x when I simplify the peanut, and that's going to be this pair here. hopefully you can see why that pair will give you negative 11x. Okay, so I'm going to complete those parts first. So let's have negative 15 x here and positive 4x here. Doesn't matter which way around you put those in. And now I'm going to look across the row. So I'm going to look across this entire row. And I can see that 6 and negative 15 have a common factor of 3. And that x squared and x have a common factor of x. And now I can finish off this grid. So I multiply 3x by 2x to obtain 6x squared. I multiply 3x by negative 5 to obtain negative 15x. Now this 2x needs to be multiplied by something to get positive 4x. That's going to be positive 2. And then I need to double check whether this positive 2 times this negative 5 gives me the right thing here, which you can see that it does. And so that's me finished. And my brackets are going to be 3x add 2 and 2x subtract 5. Remember that we found a pair of numbers that multiplied to give negative 60. The negative 60 was from the 6 multiplied by the negative 10. But you don't see the negative 60 in the grid anywhere. That negative 60 is not in the grid. What is in the grid is the negative 10 that was the last term in the original quadratic expression. So the negative 10, which came from here. But you use the negative 60 to find the right pair to put into your grid so that you get the negative 11x in the peanut. Okay, on to example 5. Now example 5, the last example, says simplify, and so you might be thinking, why on earth does this have anything to do with factorising expressions? But the point is that when you when you simplify fractions, for example, when you simplify 15 21sts, you know that you're really saying, okay, well, what goes into both? 3. How many 3s make 15? That's 5. How many 3s make 21? That's 7. So I get 5 sevenths. But what you're really saying is I can prime factorise, I can decompose 15 into 3 multiplied by 5, and I can decompose 21 into 3 multiplied by 7, and I can say this is the same as 3/3 multiplied by 5 sevenths, and of course 3/3 is 1, and so really I had 5 sevenths because multiplying by 1 doesn't change anything. So that's exactly the same process that we're going to use for simplifying algebraic expressions. We need to factorise first. So if I factorise the numerator, so my numerator is x squared subtract 4x subtract 21. So I'll do that in the grid. X squared, I'll give myself a bit more room. X squared subtract 21. I'm going to have x's here. I need a pair of numbers which are going to multiply to give negative 21. But where the peanut term will give me negative 4x, and to get the peanut term to be negative 4x, I'm going to use this pair here. So positive 3x and negative 7x, which will need a positive 3 here and a negative 7 here. So the numerator is x add 3, x subtract 7. And then the denominator, so the denominator is 2x squared add 9x add 9. Don't forget this time I need to multiply the 2 by the 9. That's this 2 by this 9. So that gives me positive 18. So I'm looking for a pair of numbers which multiply to give positive 18. And so that could be positive 1 and positive 18. Could be positive 2 and positive 9. Could be positive 3 and positive 6. Or it could be negative 1, negative 18, negative 2, negative 9, negative 3, and negative 6. Those are all the pairs that could give me positive 18 when I multiply them together. And I'm looking for the specific pair which in my peanut is going to give me positive 9x. And to get positive 9x, I'm going to need this pair here. And so I'll fill those bits in. Positive 3x, positive 6x. Again, it doesn't matter which way around I put them in. And then I'm looking across the top row and I can see that x is a factor of both. I multiply x by 2x to get 2x squared. I multiply x by 3 to get positive 3x. I'll multiply 2x by 3 to get positive 6x. And I double check the final one, and positive 3 times positive 3 will get me the positive 9. So my denominator is x add 3, 2x add 3. And then you can see that x add 3 is a factor of the numerator and the denominator. So this simplifies to x subtract 7, 2x add 3. And I'm done. So that is example 5 completed. So hopefully you can now have a go at all of the remaining questions on the Factorising Expressions pages of your book. So have a go at those, and don't forget, if you want to ask me any questions, you can send me a message on Firefly.